Hello, this is Rich, and today I'm going to be doing a pretty wonderful tutorial, something I promised a while back here. This is creating custom AI from scratch using C++. So we're going to go overhead on how to make the custom class, okay, a C++ class that controls our AI in-game. Now, this is how the AI works in Cryengine by default. For instance, you have the player, and you also have the grunts. Okay, so the grunt class and the player class are custom classes that are actually programmed in C++, and that's why you can use them in the world. So what we're going to do is we're going to create our own custom class to get our own custom AI into the game. Now, the cool thing about this tutorial as well is I'm going to be referring to an AI that I already created, something you guys haven't seen yet that I've been working on in the background for my RPG game. Now, this is not open source or anything like that, but you will get to see some of the code that I have created for my custom AI, which is a pretty cool thing. You guys will be able to see some of the code that I created, as well as it's more of an I'm using my existing class to show you how you would control your custom AI. So let's just get started on this. Let me make sure my door is closed so my kids aren't in the room, so I can smoke a cigarette. Alright, so I'm doing three things: smoking, doing a tutorial, and eating my dinner. Alright, guys. So let's go ahead and get started for the custom AI. I think what I'm going to do is I'm going to show you my AI first. It's pretty simple, as in it doesn't go anywhere, it just sits there. But there's something unique that I programmed, and we'll just get into that. So I'll show you the result. Like I said, my AI is still a huge work in progress. And this is a village worker that I've created. And we're going to show you the result. And then I'm going to show you how to create an AI. Not create the thing that I created, because it's fairly complex. And it's my code that I'm not willing to fully share, because I am hoping that this is going to be a commercial project. So I'm not going to go over how to create the exact same thing, but I'm going to show you how to create the class as a basic class, and then my code is a reference for how you can do things to change the behavior. So let's go ahead. I'm going to use the Express version. I do have the professional version, finally, thank God. But for the purpose of the tutorials, I'm going to be using the Express so everybody can follow along. And I'm going to go right into my Cryengine game. And by now, no. I'm going to use... I get rid of that.
A vast virus database has been updated.
I'm actually going to be using the professional. There's the things that I'm doing today is nothing to do with the versions, as in you can do the exact same thing with the Express. But I did recently put my code under source control, and I want to keep that workflow. And it's a plugin that actually can't be used with Express versions. So obviously you should know by now how to load up your project from my previous tutorials if you've been following along. Yeah. And I've been as you can see, and I was programming my own custom inventory system. I know Cryengine has an inventory system already, but I created my own for the sake of my RPG game. And anyways, so let's go ahead step by step and do this. This is my village worker implementation of the class. Let's go to the actual, let's see here. Let's open up both the H file and the .cpp file. Okay, so currently what I'm going to do is just run it to show you some of the results here. And it's something, you know, quick, doesn't take too long to show, but it is my custom AI. Wouldn't be possible without C++ access. But I just want to thank Crytek for just a wonderful, wonderful engine. I mean, this is just the game code that we have access to. I cannot even imagine what the actual full source code would be. I mean, this Cryengine is such a extremely powerful engine, and I'm just so happy to be working with it. It's really tough to get a grip on it at first if you're a beginner, especially if you're just still a beginner at also C++ as well. Oh no, thank you. Okay. But it's just so goddamn powerful. It's amazing. I mean, once you get to realize the things you can do with it, it is just amazing. And you guys at Crytek. Programmers over there who's working on the programming for the engine, you guys are amazing. Genius if not. I mean, the way you guys are doing things and the way things are put together, you guys did an amazing job. Amazing. I'm just able to start realizing how powerful your system is due to the fact that I myself am getting more advanced at C++. So to the programmers at Crytek, amazing, amazing, amazing job. And thank you for this system. I hopefully one day will be able to have full access by becoming a licensee. One day, hopefully.
It's more challenging because there's so many girl styles. Like, which direction do you go, like princess tutu, or do you go like boho chic? And I'm going boho chic. Kim and Chloe keep buying me tutus. I keep hearing all this stuff about some goldfish. They bought fish for Macy.
Okay, I'm going to be opening up my
The fish died.
little test level here.
Yes, we had to go replace and get the exact same fish. I don't know how people keep fish alive.
Everything here is made with default Cryengine assets except for my village hutch, which are still to this day uncompleted because I'm having an issue making straw roofs for this stupid thing. But yeah.
Okay, the fish died. Terrible, terrible tragedy. Mason will recover, and I promise you, 2 hours from now, you won't even remember the fish. But mom, you know, especially first-time moms, everything becomes, you know, so dramatic and big.
Okay.
How are we going to deal with it? It's fine.
Slower. Okay, here. I'm going to go ahead and take these two AIs. Actually, what I'm going to do is delete these AIs. And I'm going to just jump right in game here and just show you here. Just going to walk around. And I'm going to say, what are you doing? Nothing happens at all. Beautiful. Works. What are you doing? Nothing. Nothing happens. Okay. Cool. Let's go around, walk around. What are you doing? Nothing happens. What are you doing? Nothing happens. At all. What are you doing? Nothing. Still nothing. Oh, hold on. Wait till it turns day again. I like my time of day here. It's pretty nice. Anyways, let's just jump out and put the lighting back at default where I had it. So now you saw nothing happened. So now let's go ahead and we created our own class. So let's go to the AI. Before we had the flyer, AI wave, area territory, grind. Now we have a village worker because of the custom class I created. So let's go ahead and drag this village worker into the level. Okay? Into the level. And we're going to set his AI so he doesn't bother us and try to shoot us. So we're just going to change his behavior selection tree to none. So he doesn't have a behavior selection tree. And let's just go ahead and reload our scripts and reload the AI. And let's go ahead and jump right into our level. Now I'm going to ask again, what are you doing? Nothing happens. What are you doing? Nothing happens. What are you doing? Nothing happens. Okay. How about this? What are you doing?
Nothing much. Just doing my job. If you don't mind, my good lad, I have to.
What are you doing?
Just enjoying the day. Doing what needs to be done.
Huh. Pretty cool. Let me ask again. What are you doing? What are you doing? Nothing. But let's move a little bit closer. What are you doing?
Nothing much. Just doing my job. If you don't mind, my good lad, I have to get back to it.
3D space sound, as well as recognizing my speech. He's listening to me. Literally, he's listening. Him himself is listening to me speak, deciding how to respond based on my XML conversation scripting. Remember that dynamic scripting that I used back when I called my project Seaman Remake? Well, it's all completely redone. Each AI class now has an instance of their own conversation file, which decides how they respond based on their feelings, what I do, what I say. Currently, he's feeling neutral, so the things that you're saying are things that he would say if he's feeling neutral. But yeah, let me go ahead and, what are you doing?
Just doing my job. If you don't mind, my good lad, I have to get back to work.
What are you doing?
Nothing much. Just doing my job. If you don't mind, my good lad, I have to get back.
What are you doing?
Nothing much. Just doing my job. If you don't mind, my good lad, I have to get back to work.
Pretty cool. Now let's go ahead and drag another instance of this guy in here. Oh no. By the way, this happens because of speech recognition. Whether I'm in game or not, the AI still listen whether I'm within a certain radius of them. And by me talking and talking and talking, like I was to you guys in my tutorial, it's just way too much. What I was saying was way too long for the string value to hold or whatnot, so it crashed it. But yeah, anyways, that's my own custom AI. Fully done. It's able to listen to what I have to say. He's listening, not some background worker or background system. He himself is listening once I drag him into the level, if he's within a certain radius. of me. He also decides how to respond based on the conversation file that he himself loads up into his memory, and he decides how he's going to respond based on how he's feeling, the current situation he's in, what I say, what I do, and how I talk to him. So that's my own custom AI. It's pretty advanced, even though he doesn't do anything. It was still pretty advanced. But these are some of the things you can do with making your own AI classes through C++. It's just wonderful. So that's what we're going to learn how to do today. We're going to learn how to make our own custom AI. Not do the things that I do. I'm not willing to share that. But I am going to over how to make a custom AI that you can actually put into your level and have a template that you can actually sit there and program your own stuff that you want your AI to do. Maybe you're making an RTS game or whatever. Or maybe you're making a village building builder game where you build buildings or whatever. Maybe you want your guy to every morning at a certain time because, again, C++, you can access the time of day. Maybe you can have your village at every 10 o'clock. He goes ahead and he shuts off all the lights inside of the town or something. You know, you can do whatever you want with C++ and making your own classes. It's a powerful tool. That's why I'm showing you how to make this. So let's go ahead and do it. Okay. Now I'm just a single programmer doing all this, so a lot of the progress is slow. It's just me. But the good news is progress is going to pick up quite a bit because I've now recruited another programmer, actually. Recruited another programmer, so progress should be going a lot quicker. So here we go. First of all, you're going to want to do is create, doesn't matter where you create the file, as long as it's within the appropriate directory by right-clicking anywhere here. And then add new item. You're obviously going to want to add a .h file, a header, and a CPP file, source file. Okay, so name it whatever you want. So the first what you're going to want to do is create a .h file by going in whatever directory you want, right-clicking, add, new item, making sure that you go ahead and you make it a .h file, and then add. And then go ahead and do it again, whatever you want, CPP file, then add. Okay? Pretty cool. So now we got a .h file and a .cpp file. And now we're going to go ahead how to make the class. So this is what we're going to do. Here we go. Your class needs to begin with a C, very important, a capital C. So you can name your class whatever you want, but your class needs to be named with a capital C in front of it. So in this case, C Village Worker. Okay. Now it could be a struct or a class, doesn't really matter. What I'm going to do though is because it's my custom code and everything inside of here, I'm going to hide some of these here. Okay, cool. So including the windows.h file and including the SP helper file is something you would not need to do. This is something I need to do because I'm using speech recognition, so these files you can ignore. But you will, if you're creating an AI, you will need to include the player.h file. So go ahead and do that. So after you make your .h file, go ahead and include player.h. And then also make your own class. In this case, I made my class a village worker. So C village worker. And we also have to do an order. Now this is important. In order to get your to program your own custom AI, you do need to do to use inheritance, and you need to the easiest way is you need to derive from the C player. I'm not going to go over what deriving means. If you're at this point in time where you're looking to create custom AI, you should be familiar with C++. You need to derive from the C player class. Now, because the C player class has all the functionality currently in order to add AI to the game. So you're going to be creating whatever you want, capital C as a prefix, and you're going to be I'm still debugging. What the hell? Anyways, you're going to be wanting to derive from the C player. Very simple. Make your class, derive from C player. What you're going to want to do is make your constructor. Don't worry about these member initialization. Okay? But go ahead and make your constructor, make your destructor. Okay? Again, this is custom code. So just make constructor and destructor. Now, there are things that you have to be very careful on. This is what you need to do. So after you derive from the C player class for your custom AI, you need to, it's not a question of do I, it's you need to override the functions that are located in the C player. There are specific functions that are part of the C player. Let me go to them. I'm going to right click and go to definition, and you're going to see class C player. Now if I scroll down to more of the class, keep going.
We've all kind of been talking, especially like Rob and I, and we
And my bad.
really appreciate
I'll tell you the functions you need to override to be safe. We're in the C player class.
but I think you have to pay attention to the capability that might cause your children. Like I was trying to play along and make it funny, but it's not.
Now, okay.
It's not playful.
Starting here at the init, if you see this right here, starting at the init function, you're going to take everything from the init function all the way down to get memory usage. See that? All the way from init, all the way down to get memory usage. You're going to right click, you're going to copy, you're going to go to your custom class, and you're going to paste. Paste right here. Copy, paste, which is what I did. And you're going to end up with all of these here. These are the functions that need to be overridden for your AI to work. You guys should already know what overriding functions is. These are from the iGame object extension, functions that you're overriding. And these right here are from the actual C player class we've seen. Handle event, on collision, and kill. Down here are member variables that I have created. You can create whatever you want, whatever you need for member variables, but that's it. That's all you got to do, guys. Honestly, that's all you got to do. Create your own class, include player.h, derive it from C player, and then override all of the functions from the C player class. That's it. That's it. That's all you got to do. And this is part of it too. Override all these functions. Pretty cool, in my opinion. That's all. That's all you got to do. Now you get your own custom class. Own custom class. Next, what you're going to want to do is go to the game files. Gamefactory.cpp. Scroll down. Now, you need to let the engine know you have a new class that you want to use in the editor, and that you want to use it as a class that implements a AI. So what you're going to want to do on the init game factory function is you're going to want to register factory. You're going to want to use this macro, register factory. This takes care of creating game objects, some of the initialization, telling that your AI that you've created is going to be using your class to control it. So you're going to be using register factory. Okay. And the first parameter is the class that's going to be registering. In this case, it's a pointer to the game framework. And so just use p framework. The second parameter is a string value, which tells the name of the class that you're making. In this case, we want our class to be named Village Worker. So when you go in the editor and to find your class to add, it's going to be Village Worker. So that's the name that you're making it. Also, if you want to Lua interactivity with your class as well, if you want Lua to be able to control your class through script binds, you're going to want to be looking for this as well. So when you create your Lua file, when you make the first table that is blank equals, and you make that whole Lua table, this is going to be the name of the Lua table as well. So this is the name of the class that you're registering, what you want to name it, Village Worker. And also, if you want to make a Lua file associated with this, the Lua file needs to be named what you put here, villageworker.lua, and the table needs to be villageworker equals, and then you put the table. That will add Lua interactivity to your class. The third parameter is the class that's going to do all the handling of your class. In this case, C village worker. So if I go here, we're going to see that what's going to be controlling our class, what's the handling, what is going to be doing all the processing and the work of our class. It's going to be this, obviously. When we put the AI in the level, we want this class to be controlling what the AI does, C village worker. So that's the third, is the implementation, what's going to be doing the handling. And the fourth parameter is if it's going to be AI or not. And in this case, yes, it is an AI, so let's go ahead and put true. If you put true here, what's going to happen is it's going to show up in the AI section on the entities in the roll-up bar. And if you put false, it will not show up in the AI bars. But it still could be a class, but you're just going to have to spawn this class dynamically. But if you add true here, it's going to add it to the editor so you can drag and drop and let it know it's an AI. Pretty cool, I think. So there you go. I created my own class. Okay. I derived from C player. And then I overridden all the functions of C player. You guys should know what overriding is. So I override all the functions of C player. At the end, I just register it. I say, yep, my class is all ready to go. It's all set up. Now let's go ahead and register it so the system can use it and add it to the editor. So the first parameter is the class is going to be registering. In this case, it's almost always P framework. Second parameter is a name you want your class to be registered as. This is going to be the name of the class. It could be whatever you want, as well as it's going to be the Lua table name. Okay. So if you want a Lua file associated with it, it's going to be the Lua file needs to be named villageworker.lua, and the table needs to look like villageworker equals. Third is the actual class that you want to do handle all of the code and stuff like that. In this case, we want our C village worker class to do all of the handling. And the fourth parameter is whether it's going to be AI or not. True for a yes, false for no. This also will control, if it's true, it'll add it to the editor so you can drag and drop it in the game. If this is false, then you're going to have to dynamically spawn this entity at runtime, like the player. You can't drag and drop a player into the level, can you? No. That's because the player was registered as false. So the player is actually spawned at runtime when you start the game. The grunt, on the other hand, is true, and it's going to be added to the editor so you can drag and drop it. Now here's something interesting. You guys may think that the player and the AI were two different classes. See, that's false. What actually happens is the C player class, which is the class we derive from, does the handling for both the player and the grunt. Both. So the C player class is the stuff that does the handling for the player and the grunt. So it's only one class. So we're making a class C village worker that does the handling of our village worker. Pretty simple. Pretty simple. So just one more thing in case you guys aren't really clear on this. When I drag and drop my person into the editor, all the functions that my AI can call and all the stuff it does is everything that's inside my C player class. Very simple. So if I want to change the AI's behavior, change its model, change its scale, its size, its position, give it new commands, all this stuff needs to be done in the C Village Worker class. Pretty simple. That's it. By this time, your AI will be in the level, in the world, and you can drag and drop it. It's not going to be any different than the C player. Why? We created our own class. Why won't it do anything different than the C player? Well, that's because we didn't tell it to do anything different, and that's where the magic happens. We derive from C player. So we have all the same functionality from C player because we derive from it. Now, in order to make our class different, in the functions that we overrided from C player, and all the functions that we overrided for C player, we have to do something different in these functions. So let me go ahead and do some of the functions. Init is an initialization. When you drag and drop your character into the level, it calls the initialize function automatically. And you do need to do something in initialize. So again, we're just going over getting your custom AI to work at the basic level. So let's go ahead to the init function. What you're going to want to do, you don't even need to worry about this if you don't want to, quite honestly. Just ignore this. You don't have to do that. But you're going to want to call set game object, and you're going to want to put the game object that you want to use your class to use. You have the C Village Worker init gets called automatically when you drag and drop your character in the editor. But when your character gets dragged and dropped into the editor, the engine automatically makes a game object for it. And it goes ahead and it passes that game object into the init function. When we're in the init function, we say, hey, class, we want you to use that game object as the game object. So now at this point, our class has a game object associated with it. So we're going to say set game object needs to be done. So when you initialize, you need to set game object and then the pointer to the game object that was sent along with the init function. You don't want to do anything else in the initialize function that's going to be controlling your AI or entity. Bad idea. You can use it to initialize variables if you wanted to, but don't do it to control your entity or your AI, because technically at this point in the stage your AI isn't even ready to go yet. Your AI is ready to go once the post init function is called automatically. Again, post init was one of the overridden functions that we made here. Post init. So we added our own code in it. And now at this point, at the post init, when it gets called automatically, also the pgame object is sent along with it. We can do stuff with our AI at this point in time. At this point in time, I chose to initialize my speech recognition listener so he can listen to us, and to initialize his voice speaker so that he can speak to us. And then I also, this class also has an update function, and you guys should know what update functions are. Update function gets called every frame. So every single frame of the game, your code is going to get called over and over and over every single frame. So if your game runs at 60 frames a second, then this update function is going to be called 60 times in a second. Got it? Okay. And the update function gets called automatically by the system. Every frame, the update function gets called automatically. Now, the trick to this is if you want to do code or modify your class every single frame, which is a good idea to do most times, maybe sometimes you don't want to, but the system does not call your class's update function every frame unless you enable it. It's like a feature type of deal. Because updating, when you have maybe hundreds of entities in the world, can be pretty expensive to update them every single frame. you may not want to have your class update. So it's in there as a feature. You have to actually manually tell it, yes, I want this class to be updated every frame. And you do this in the post init function. You can't do this in the init function, again, because you're telling your game object to allow updates with this function. And at this point in time, even though you set the game object, your game object isn't ready to go. So you end up with some access read violations here. So in the post init function, your object's ready to go. It gets called automatically by the system. You're telling it to do whatever code you want to do. In this case, I told it to initialize my listener and the speaker for it. And I also say, hey, game object, again, because our game object is passed as a pointer along with the post init function. We're saying, hey, p game object, enable update slot. And the two parameters are very simple. The first parameter is the game object extension. Is the game object extension that you want to enable updates for. And our class can be looked at as also as a game object extension, pretty much. See, our class that we're actually working with here, our class, is pretty much known as a game object as well. Just think of it like that. So we're going to take our p game object and we're going to say, hey, enable update slot. And every object, entity and game object has slots, slot 0, slot 1, and you can add different things. Like I could put a model in slot 1, I could put a model in slot 2, put a model in slot 3, so our one entity can have 3 different models, you know? You know what I'm saying? Maybe I could have a body with no arms and no legs and put it in slot 1, load it up in slot 1. And then I want to add some arms. So I can say load up this arm, or this model, which is an arm, by the way, into slot 2 and set that position a little bit over so it looks like the arm is attached to the guy. So each game object and entity has slots that you can load different models and stuff into. So in this case, our default slot is 0, which is the one that we're going to be using. So when we enable update slots, what the first thing we want to do is tell it which game object extension that we want to enable updates for, or which class that we want to enable updates for. And the second is what slot you want to enable updates. Since we haven't loaded anything else in the slots, 0 is our default. So we're going to say pGameObject enable update slot. This is actually a keyword that's a pointer to the object instance that called this function. So our C village worker obviously calls the post init function. An object of our C village worker obviously calls the post init function. So this is just a pointer to the object that's calling it. So it's itself. Basically, it's itself. I want pGameObject enable update slot of this, meaning of this class. I want this class to enable update slots of myself. I want myself to be updated every frame. And then the slot 0, obviously. So there we go. So the first function that gets called automatically, init, when we add our object to the level, or if we spawn it dynamically, the init function is automatically called. Here we set the game object to say, yep, there was a game object created automatically for us when we spawned the entity, and we want our class to use that game object. We want to attach to that game object. And by the post init function, it gets called automatically. And by this time, our entity is ready to go, and we can do stuff with it, like set its position and do all that funky stuff, change its material, or whatever you want to do with it. But we also say, you know what, I do want to have also updates to, I want our entity to be updated every frame, because maybe I have some stuff I want to do every update. In this particular class, yes, I do do things in the update function. So I'm going to say, hey, game object, I want you to be able to update on slot 0. Pretty cool. Oh, by the way, people who actually know programming quite well, you see this? This, if you don't want to use this, I haven't done it before, but I'm pretty sure you could do something like this. Why you even need to specify which you want to update, I have no idea. Again, I'm talking to the people who know what they're doing. Probably better than me. But because of the way the hierarchy of the classes work out and how things are extended from, derived from class to class, you can actually take your pGame object and it won't go here, but you can perform a dynamic cast. I'm not 100% sure on this. And it takes iGame object extension in this first parameter of the enable update slot, so you can just cast it to an iGame object extension. Pointer. No, I guess not. I guess not. Never mind. Go ahead and use this pointer. Trying to be fancy, but you can't actually. But there we go. And after this, again, all of these functions that you've overridden get called automatically. So you can just look over here, the update. See if we want to do something every frame, we can. So let's go ahead. We overrode that update function. And update. And here we go. Every update, I want to check if the I made my own function, get distance from player. So this village worker is every frame is going to get the distance from the player. And it's going to check if it's less than or equal to 5. And I'm also going to check if the village worker is listening. And if it's not listening, then go ahead and tell my speech recognition software to, Microsoft speech recognition software actually, not mine. Engine to listen to us, to tell it to listen to us, and set it to listening. And I'm also going to check that if our distance is more than 5, with this else, we're going to check if it's listening. If it is listening, then we're going to say don't listen anymore. We're more than 5 meters away from the player. Don't listen to me. Don't even listen to my voice. Pretty simple. Now I do use obviously Microsoft speech recognition in the SAPI API, but I've extended their system quite a bit with my own, and that's why my speech recognition software, not mine, but because I've had a lot to it, I call it mine, but it's really not. But my part of the extension that I've made to the speech recognition, it's incredibly accurate. No joke. My system makes Microsoft speech recognition incredibly accurate. Because, now, this is just a technical fact, not part of this tutorial. Kind of boasting a little bit. What actually Microsoft allows, the speech SAPI allows you to actually create grammar files, and grammar files are basically rule sets that you can optionally put to use a grammar file to say, hey, what I want you to do is I want you to listen to specific words only listen to specific words. So by using the grammar files, you're able to increase the accuracy quite a bit because it's only looking for those specific words to be said, and it just increases the grammar, the accuracy by a lot. Now, here's the deal though. I'm not using a grammar file. All the things that I am doing is all dynamic, pretty much what's that word for it? Dictating. I'm in dictating mode. In the dictating mode, Microsoft SAPI does do a good job, absolutely. But it wasn't good enough for the type of quality that I wanted in my game. I wanted to be able to go up to somebody, say whatever I wanted to say, and have them know what I'm talking about, and be able to recognize things that I say. And just because it didn't understand, maybe you didn't understand one word, I didn't want it to know that's not what you said. So I went ahead and I programmed my own system that takes what SAPI thought we said, and bring it over to my API, and I go ahead and I do some conversion, I do some checking, I do some mathematical equations, and I decide whether if it's appropriate recognition or not. That's what I did to it. Because when you're in dictator mode, it's not looking for specific words. It's looking for you to say anything. So it's a lot less accurate. Let's put it that way. It's a lot less accurate because it doesn't know what you're actually trying to say. My part on the extending the SAPI API for my project here, I'm pretty damn proud of my AI and what it's able to recognize. But anyways, on this M listening, if it's listening, if the guy's listening and I'm more than 5 meters, see what else, if I'm more than 5 meters away, I go ahead and I tell my speech recognition software, Microsoft, SAPI recognition software to stop listening to me. Every frame I also get what the speech recognition software thinks I said. Blah, blah, blah. I get what it thought I said, and then I go ahead and call my own function on player speech. Okay. And I go ahead and call my own function on player speech. So every frame I'm going to be looking at the distances I am that the village worker, a village worker is the distance he is away from me, the player. And if he's close enough, then if I'm close enough to the player, I mean the village worker, he's going to start listening. And if I'm not close enough, he's just going to stop listening to me whatsoever. And when I speak, I do some stuff here. I'm not going to explain it, but I'm going to do some stuff here when I speak. And whenever I say something, it goes ahead and it sends over to a function I called on player speech, and with the words it thought I said. And then I'm also going to get the distance from the player again. And I do some work here. That's very simple. That's all you got to do. So in order to make your own custom classes, you make a .h file and .cpp file, make it whatever you want. Make a custom class, include player.h, and derive from cPlayer. Once you're in cPlayer, go ahead and override all of cPlayer's functions. Okay, override them all with your own custom values. And if you don't have anything to add to what they did, if you don't want to have any custom code, you still need to override it by at least giving it, declaring it here. Okay, very simple. Override cPlayer's functions, and here we go, player functions, and you create your own. Like I created my own functions here, and very simple. That's it. That's all you got to do. That's how you create a class. One more time. In order to create a custom class for AI, you need to make your own class, derive it from cPlayer, override all of cPlayer's functions, include player.h, and then write your own code in the overridden functions. Write your own code in the overridden functions for your AI. Pretty simple. After you're done that, go ahead and register your AI. Say, register your class. So you use in the game.cpp file, make sure you register factory. P framework is pretty much always going to be used here. They're a pointer to the game framework. The name you want to register your class as, the class is actually going to be doing the controlling of your class and whether it's an AI or not. Pretty simple. False means it's not going to be added to the editor. True means it will be added to the editor. Plain and simple. Alright guys, I hope you enjoyed, and thank you very much. And if you like my AI, how it's coming across and how it's working, then let me know. And sorry for the corny voice, I'm no voice actor. But, alright. Thank you guys very much, and I really appreciate it. Oh, I want to show you something else that's pretty cool. I do. How do I want to do this? This is for testing because I haven't integrated my voice into the XML data. So again, this is not how my system works here. For all you guys who kind of understand what I'm doing here. This is final question data is actually data that's contained in the XML, and M question refers to the question element in my XML file. I don't do checks like this through my game. That's the whole point. This would be manual work, okay, manual by checking if this phrase equals what's in here. How many of these would I need to check? A lot. For every conversation, I would say, does this equal this? Does this equal this? No. My system is dynamic. It controls, through my XML file, it controls all of that dynamically. But I wanted to add the feature of doing voices. Instead of my computer doing the voice, instead of going, the computer saying something, I want it to be a human voice. It was a test. I was testing to how to get sounds working through C++, so that's here. What actually is going to happen is you're going to, in the XML conversation scripting app that I made, the visual scripting app that I made for making dynamic conversations for each AI, you're going to specify in there a voice file to play. Very simple, a voice file to play. A string value with the voice file to play, and then you're just going to go ahead and speak, and then question data dot m voice. But yeah, since I was just testing voices, I did checks because the voice file is not part of my XML yet. But once it is part of the XML, I won't need these individual checks. But yeah, so let's go ahead and I don't need all of this. I'll get rid of all this. Comment. There, I commented it all. What are you doing, Rich? Whoops. What are you doing, Rich? Oh no. What are you doing? I'm showing you something. That's what I'm doing. Hold on a second. I'm trying to convert it back to the original, how it originally was without the real voices. So I'm doing some weird conversion here from a string to a wide string. Just so you guys know what the hell I'm doing. My speak command takes a long pointer to a wide string. Alright, go ahead. Oh my god. Oh my lord. Hold on. Alright, hold on. I don't know why this function is not working. Okay, yeah, I see the issue. I had to look at my old code, how I did that before. I gotta use the standard libraries W string. Anyways, there we go. All dynamic. I just tell it to speak whatever's in the conversation file, whatever decided with. I don't do any checks, no nothing. I don't say if this equals this, if this equals this. It's all commented out. Say, I want to convert it to a W string, a Y string, and then tell it to speak whatever it's supposed to. And it'll speak whatever it's supposed to, all dynamically. Before you saw I had if this question equals blah blah blah, do this. That's only because my dynamic system did not include the sound file in which to play. In other words, when I say speak, I'll just use, instead of the phrase I want the computer to speak, I can just put the sound file that's within inside of the XML file. That's the only reason why I did manual checks, because it was a test for sound to work. But anyways, let's go ahead. Oh no. Oh yeah.
And I'm really glad that I did do the solo interview. I don't know what just happened there, but that was delicious.
There we go. Man, I haven't had a cigarette in a while. I'm all done with the tutorial. I'm just showing off something cool. Something cool. I have two ways for AI to speak. One, through text. Two, through actual voice files. So you can choose whatever you want. If you want a more realistic human sounding thing, you might want to use a voice file. With mods, I'm saying after my game is released, you'll have mods that you can add new. With my scripting app, you can add new apps, and you can do voice files, or you can do just from text, have the computer speak text. So I have two ways to control my AI through speaking. There are advantages to both. The advantage to the voice is the voice file, or the WAV file, or whatever kind of file you want to use. I use Fmod with actually events, but you can use WAV files if you want. Advantage of that, obviously, it sounds realistic because it's actually a human speaking in the game. If you're speaking to a human, you want a human voice. But with the computer voice, when it reads from text to speech, you can actually get the advantage of that is you can get him to say things otherwise wouldn't be possible. And I am speaking. Hold on, let me just shut up. What are you doing?
Nothing much. Just doing my job. If you don't mind, my good lad, I have to get back to work.
What are you doing?
Just enjoying the day, doing what needs to be done.
What are you doing?
Nothing much. Just doing my job.
What
If
are you
don't
doing?
mind, my good lad, I have to get back to work. Nothing much. Just doing my job. If you don't mind, my good lad, I have to get back to work.
What are you doing?
Nothing much. Just doing my job. If you don't mind, my good lad, I have to get back to work.
What are you doing?
Just enjoying the day, doing what needs to be done.
As you can say, I have two different ways for my AI to be played. One with voice and one with actual text-to-speech. The difference is with text-to-speech, I can get it to say things you can't do with voices, meaning Dynamically, I can add new responses. Dynamically, I can teach my person how to do it, because I can obviously generate new strings, new words to say. But with a voice actor, you actually have a limit. Why? Because you have to record every single file. So if I want to say something that, say if I want my AI to learn, for instance, okay, I want to teach him new things, unlimited, of course he can do that. Why? Because he can always read speech from the computer, right? But you couldn't do that with normal voices, because you have to have a recording. You have to actually know what people are going to say, because you have to have a voice file. I think you guys will understand what I'm saying. With using the text-to-speech, so much more capabilities for teaching, learning, and saying new things. But when you're using a voice file, it's more realistic, yes, but it kind of limits what you can do with it in terms of you have to have a voice recording for each particular file. For instance, with voice, I can say something and have it store my name, Rich, so I can get the computer to say Rich. Why? Because it can read the word Rich and it says Rich. But if I'm playing the game and some guy named Joseph playing it, if I don't have a recording that has the same exact phrase but the word Joseph in it, like if I said, hey Joseph, how are you? Right? Now what if the person playing the game wasn't Joseph? His name was Marcus. I wouldn't have a voice recording with Marcus. It's impossible for me or a voice artist or voice recorder to know what people are going to say and do and what people's names are. So you can easily see how the text version has its advantages over the actual voice file, and the voice file has its advantages over that. So I left them both in there for the user to decide what they want and what they want to use. It's going to be default with the voice. But if you want to get some cool, if you don't really care, if you just want to play around and you don't care about how the voice actually sounds, and you want to be able to teach your AI new things and about the world, how to respond to different things, then you're going to want to use the text-to-speech version. You can teach him to say your name because he's just reading from text. You can teach him to say new things because it doesn't matter if you had a voice recording for it. All he's doing is saying the speech that you wrote down or dynamically generated during programming. So I left them both in there. You can see this, the voice. Yeah, I'll save it. The voice, right? Or you can do the dynamic speaking. And in this case, I got rid of the dynamic speaking for now, and went with the voices for a test. Now that I know voices actually work, I can go ahead and integrate that into my XML file for the speech XML file, and also integrate that into my app to have him do a voice if you want, an actual voice. I don't have to do checks anymore since I found out that it does work. I can just integrate that into the scripting app that I made. No, I'm But there you go. That's how you create a custom AI, and me showing off a little bit of my stuff that I've been working on my RPG game. Thank you guys very much, and I hope you enjoy. If you have any questions, remember I'm right here. All right, bye.